Okay, this is your final exam for outcome N3 on rational numbers, both comparing and ordering, as well as operations with rational numbers in both fraction and decimal form. Your first few questions are true and false. The first question says, is negative 1 and 3/5 greater than negative 2? Is that true or false? That is true. And the reason why is if we think about a number line, this being 0, -1, and -2, negative 2 would be here. And negative 1 and 3/5 is just a little bit more than that. So when we deal with negative numbers, the closer you are to 0, the larger it is. So therefore, the answer is true. And probably up here you would have 1.6 and say something like this is 1.6, -1.6, this is -2, etc. Question 2, we have -1/3 is greater than -0.3 repeating. The answer for this is false, because if we change -1/3 to a decimal using a calculator, or there we go, and say what is 1 divided by 3, it will tell you it's decimal 3 repeating, which is exactly what the other side is. So in order to show you're working, you just say they're equal. They're not different. They are equal. Question 3, I love this one because so many smart people got it wrong. 0.20 is equal to 1 over 20. The answer is false. And of course, the easiest way to do it would be to say, well, what is 1 over 20 as a decimal? So 1 divided by 20 is 0.05. So therefore, the question really could be, is 0.20 equal to 0.05? No, it's not. It's false. This one actually should be greater than. Question 4, if we think about which one is greater, we're going to have to work this out. This is going to be negative something. Because if we have more negatives than positives when we combine, we know the sum of those two will be negative something. It's not really important what it is. And over here, it's a negative times a negative, which will be a positive something. So without going into too much significant detail, I know that a negative something will never be greater than a positive something, so therefore it's false. That's the best answer of them all. If you actually worked it out to a number, um, you showed me too much information, because really what I wanted you to do was show me that a negative something can never be greater than a positive something. And finally, question 5. Here's what I wanted you to do. I wanted you to realize that a negative times a negative is a positive, and a positive times a positive is a positive. So we know that both answers are going to be positive on both sides. 1.25 is the same thing as 1 1/4. 4.4 is the same thing as 4 2/5. And therefore, regardless of what the numbers actually work out to be, you are multiplying the same things on both sides, and therefore it would be true. Now, if you wanted to work it out, you could. But again, it's a true-false question. You got to look for the shortcuts first. They will both yield the exact same answer because they're the exact same numbers, except in fraction and decimal form. The only difference between them is the negative and the negative, but because the product's positives, the answers will be the same. For the next parts of the questions, and I know my questions kind of messed up because my computer didn't understand this was a real question. It says use greater than, less than, or equal to sign. So what we want to do when comparing them is have them in the same form. Now, there were a couple students who decided they wanted to compare them in fractions with common denominators, but the easier way is to simply take your fractions, like 1/5, and do 1 divided by 5 to change it to a decimal. So negative 0.2 is the decimal version of that rational number. And when I compare that to negative 0.5, remember what we said before, the closer a negative number is to 0, the greater it is. So therefore, that would be your larger number because it's closer to 0 as a negative number. Question 2, kind of like the next question in this particular one, it's kind of like that true-false that a lot of people got wrong. You're going to have to change this to a decimal first. So if I change 3 and 1/8, a lot of people know that 1/8, if I do 1 divided by 0.125, so the conversion of negative 3 and 1/8 would just be negative 3 and 125 thousandths, and then negative 3.18. Which one is greater? Well, this is, if I think about that number versus the same matching number of significant digits. Negative $3.12 is closer to zero than negative $3.18. So therefore, this is the greater number in terms of its proximity or location to zero as a negative number. And finally, your last greater than, oh, there's two of them. Is there one left or this last one? Yeah, okay. So this time we have two fractions, so we could do the common denominator one, and maybe just for differentiating between the two methods, I'll do both. If I look at it in fraction form, this would be 13/5 is greater than or less than 22/29/11. If I find a common denominator, I'll use 55 as my common denominator to compare them. That would be times 11 would be 130, 143. And over here would be times 5 would be 145. So if I look at those two fractions as common denominator fractions or equivalent fractions with common denominators, which one is greater? Since we're dealing with positive, 145 55ths is greater than 143 55ths, and therefore we have to use that symbol. Now, alternatively, 2 decimal whatever and 2 decimal whatever. The 3/5, if I change that part or this fraction part to the decimal part of this number, I say, well, what is 3 divided by 5? So 3 divided by 5 is decimal 6. So therefore, 2 3/5 is equivalent to 2 decimal 6. And 2 7/11, 7 divided by 11, is 0.63 repeating. So because this is a terminating decimal, it ends, I have to put a 0 there to compare place values. And when I do so, 2.60 is not as big as 2.636363, and therefore I would use the appropriate symbol for that one as well. And your next question, your last question in this particular field is negative 10.25 compared to negative 10 and 12/36. This one I can do in my head, and I'll tell you why I can do it in my head. Is because in lowest terms, because both are divisible by 12, is the same thing as 10 and 1/3. And the reason why I can do it now in my head, I know that 1/3 is 0.3 repeating. So this is going to be negative 10.333 ... forever. So in comparing that to this one here, because we're talking about negative numbers, we're talking about the larger number is closer to 0. Therefore, this one is closer to 0 as a negative number, and therefore is the larger of the two. Now, question 6, or I guess it was question whatever it is on your test. Is it 11 and 12 or 10 and 11? Okay. A lot of people screwed this up in terms of how to organize your work. So please pay attention. If you mess this up, and about 10 of you did, pay attention how we do this. The first thing I wanted you to do is first change all 5 of these rational numbers to the same form, whether it's going to be all fractions with common denominators or all decimals. As we talked before, it's easiest to change them to decimals. So 1/5 as a terminating decimal is 0.2. 0.222 is 0.2 repeating. 1/20th is not a common one, but if you do 1 divided by 20, you get 0.05. So 0.05 is a terminating decimal. 1/3 will be 0.333 repeating, and 0.18 is a terminating decimal as such. So that's step 1. Okay, you don't get marks for that. That's just the first thing you had to do. And once you did that, you could place them on the number line. Since we're dealing with proximity to 0, I'll put 0 here, I'll put a half here, and I'll put 1 here. So once I have my number line, I'm just going to put these in order on the number line. Actually, you know what I'm going to do? I'm going to first rearrange them. So the smallest number, because I'm doing it in ascending order, or smallest to largest, if I think about money, and since I only have 1 decimal, I'm going to put a 0 there. The smallest amount of money is a nickel, right here. But remember, I don't want you to put that number. I want you to put its starting value, which was 1/20th. So that is the smallest number. And I'm going to put my line through here and a line through there to first identify that's my smallest number. And then my next smallest would be 20 cents. No, 18 cents. So 0.18 is my next smallest rational number. And then I'm going to do 20 cents, which is 1/5 then 22 cents, which is 0.2 repeating. And then finally, my largest of all those numbers is 1/3. So this right here, what I wanted to see, because you were highlighting your answers, is this is the part I wanted you to highlight, right? Because that shows me you've reordered it, which is what it says. Rewrite the rational numbers in ascending order. So that takes care of that, all right? And now your second part for the last remaining point was to place those numbers appropriately on the number line. The 1/20th is really, really close to 0, so it goes right there. 0.18. If we talk about 50 cents and we're talking about 18 cents, maybe right here, which is 0.18. Then 1/5 is just next to it. Something like that. You can put it up top so you don't jam everything up. And then right next to that would be 0.2 repeating. And then even though I'm way off on this because I've now screwed this really bad because it should be only 1/3 of the way over. It's close to 1/3. Something like that. Okay. Now I know that I made the numbers too close together and putting them on a number line. I wasn't even that concerned. As long as I saw this and I saw you attempted to somehow put said numbers on that number line, I didn't care too much, right? Because it was tight quarters. But this was worth 2 points to do this, or 1 point for this, 1 point for rearranging them, and 1 point for placing them on the number line for 3 points total. For your next question, same idea. So we're going to change these all to decimals. Now, a lot of these I can do in my head. So this is 2/3 is decimal 6 repeating, so I'm just going to change it to that. -6.6 terminating decimal. So what's probably helpful is since it's -6.6 repeating, I'm going to put -6.666 ... There's some significant decimal places because I want to compare them. Since this second one's terminating, it ends there, and the rest are really zeros, so I'm going to put 2 zeros down, only for comparison's sake, right? -31/5, grab me a calculator. I go, what is 31 divided by 5 to change it to a decimal? It's 6.2 terminating decimal. So 6.2 terminating, just like the last one. I'll add a couple zeros just for comparison's sake. -6.67 repeating, which would be 67676767. Well, I'll just put that down. And finally, -6.5 would be -6.5. And I'll put a couple insignificant zeros for comparison's sake. Now remember, because we're dealing with negative numbers, these are all negatives. I'm going to start with 0 there. And I'm going to start with -1 here. Because, oh no, it's not -1. I'm going to have to go, actually not negative. I'm not going to start with 0. I'm going to start with -6 here. And -7 here. That's probably the best way to do this because all of my rational numbers fit between -6 and -7. Okay? So if I rearrange these, I want to think about what is, technically because it's negative, I want to think about what's the smallest number, and that's this one here. So therefore, the smallest, sorry, that's the largest. The smallest is the farthest from 0. Almost screwed myself there. So the smallest would be the farthest from 0. This is the farthest from 0, so -6.67 repeating is your smallest number. The next farthest from 0 would be this one, which will be -6 2/3. That's your next smallest. Next farthest from 0 is this one, so -6.6 terminating decimal. That's done. Next smallest is this one, which is -6.5 terminating decimal. And therefore, your largest number, or your closest to 0, is -31 fifths. Okay, highlight that with your golden highlighter. And that is the 5 rational numbers reorganized in ascending order, or from smallest to largest. There were a couple of really bright people that wrote those backwards, and they just lost 1 point. But they did show me this work here, and they got their points. Now, attempting to put them on the number line, -6.67, if we think of this as being -6.5, -6.67 repeating, be somewhere around there. -6.6 will be right next to it. terminating decimal, negative, oh, that's 2/3, 6 decimal 6 repeating. Oh, that's that one. And then right next to it, negative 6 decimal 6 terminating decimal. Then negative 6 decimal 5, which is already there. And finally, your last one, what was it again? I messed this up, didn't I? 31 fifths. 6 decimal 2, right around there. 31 fifths, right there. Okay. Question 8, estimate, then calculate. You receive 2 points, 1 point for the estimation, 1 point for the calculation. So if I think about this as being many different ways, since I said to the nearest place value, you could make this 0. 0, take away positive 2. A good estimation would be negative 2, right? Or if you made it 1, a good estimation would be negative 1, depending on what you made it. Determined what estimation you used, but I was very flexible with your estimations. For your calculation, if I keep flip change and I'm adding them, what do I have more of, positives or negatives? The answer is I have more negatives. So in order to determine how many more of these, I'm going to subtract the one I have less of. And I have 1.22 more negatives than positives, so therefore, that is my calculation. Question 9, the sum of these two. So if I'm estimating, it's going to be negative 6 plus 1, which is a negative 5 estimation. If I'm calculating, what do I have more of, negatives or positives? I have more negatives. How many more is the difference between your positives and negatives? Subtract. I have 4.74 more negatives, and therefore that is my calculation. Pretty close to my estimation. Question 10 is the product, estimate and calculate. So it's a BEDMAS question. So estimation will be negative 3 take away 4 times negative 1, or negative 3 take away, what is 4 times negative 1? It's negative 4. Remember, this is a subtraction sign, not a negative sign with the 4. So that has to come down as a subtraction sign, and the product of 4 and negative 1 is negative 4. At this point, keep flip change to give you 1 as your estimation. For your calculation, let's be lazy here. Let's just take this and move it over here. For your calculation, I'm going to put negative 2.5 take away. Grab my calculator because I cannot do this mental math. 3.8 multiplied by 1.05 negative equals negative 3.99. So bracket negative 3.99. Now I'm going to, you can use a calculator. So a smart person is going to go 2.5, make that a negative. Take away 3.99, which of course is a negative, and press the equals button. Your answer will be a positive 1.49 compared to my estimation of 1. My estimation and my calculation were pretty close. Question 11, estimate. So I'm going to make it negative 8 take away 3 divided by negative 10, or negative 8 take away a positive 3 if you want to think of it that way, because you're going to keep flip change to get negative 11 over negative 10, which when I divide it will be a positive 1.1 estimation. Positive 1.1 estimation. A lot of people had a hard time combining these two to get negative 11. In the calculation part, again, you're allowed to use your calculator, it makes it that much easier. Take your calculator and go, what is 7.5, make that negative. Take away 2.9, the answer is negative 10.4. Divided by 10, so just hit divided by 10, which of course is a negative 10. And the answer is positive 1.04 is your calculation, which is pretty freaking close to your estimation of 1.1. Question 12, we get into the fraction sense, which, believe it or not, a lot of people did better on the fraction sense than they did with the decimal sense, which doesn't make sense because you had a calculator for the decimals, right? Fractions can't be done in your calculators unless you're some kind of super genius or have a calculator that can do calculations with fractions. Common denominator will be 36. That'll be 936 plus negative 4 when you create the equivalent fraction. So many people stopped doing this that I gave up trying to take off marks. But I said I wanted to see that work, which meant your final answer was 536 when you add those numerators. 9 plus negative 4 is a positive 5. Question 13, same thing, common denominator being 40. Equivalence fractions, like this. Oh, this was so disappointing because now you subtract your numerators and keep your denominator. 8 take away 25, or 8 plus a negative 25. You have more negatives. You have 17 more negatives, which is negative 17 over 40. Negative 17 over 40. Question 14. First thing you do when you see a mixed fraction is just convert it to improper. So 10 times 1 is 10, plus 1 is 11. So it's negative 11 tenths, plus 5 over 2. Common denominator is 10. First fraction doesn't change. Second fraction does. You're now adding two fractions with a common denominator. So negative 11 plus positive 25 over 10 is 14 tenths, which is 1 and 4 tenths, which is 1 and 2 fifths. Question 15, whole numbers. Treat whole numbers when dealing with fractions as over 1, multiplied by negative 10 thirds. Cross reduce if possible. You can't, so negative 40 over 3, which is negative 13. That's 39 and 1/3. Question 16, almost the identical question, except your second number is a whole number. Treat it as a fraction over 1. Now, if you didn't cross reduce, ain't no thing, because you get negative 30 over 8, which is negative 3 for 24 and 6/8, which equals negative 3 and 3/4. Question 17, division of fractions. You were always told the easiest way, you have two options. You can find a common denominator of 14 and use that method, or simply multiply by the reciprocal. So we're going to multiply by the reciprocal of 4/7, keeping in mind I want to keep my negative sign always in my numerator. Multiply the numerators. Now look, a negative 1 times a negative 7 is a positive 7. 2 times a 4 is an 8. So your final answer is a positive 7/8. Question 18, 1 and 3/20 divided by negative 3/4. Change this to 23/20, multiplied by the reciprocal of negative 3/4, which is negative 4/3. If you cross reduce, please make sure you do it properly. If you do it, watch this. Divide both by 4. Physically write it down. That's negative 1 over 5. Multiply your numerators, you get 23 negatives. Multiply the denominators, you get 15, which is negative 1 and 8/15. If you didn't cross reduce, you got negative 92 over 60, which is, in lowest terms, both can be divided by, well, for sure by 2. 45, 46. Negative 46 over 30. Divide by 2 again. Negative 23 over 15, which takes us right to this stage right here. And we end up with our proper answer of 1 and 8/15. Cross reduction is definitely easier. Question 19 is your last question on your test, correct? 2 and 7/10. I'm going to just keep that as 2 and 7/10 right now. Plus, when I multiply this out, 5 over 8 multiplied by negative 8/5. What makes this beautiful? It's such a beautiful cross reduction. 5 over 5 is 1 over 1. Negative 8 over 8 is negative 1 over 1. So when I work this out, it just works out to be a solid old -1 over 1, or just -1. And here's where it paid off to not change this first fraction to an improper fraction to start. 2 7/10 plus a -1 is just 1 7/10.